one. All right, we are live with Ryan Cerny, and we are covering. Sorry, I got a lot of feedback, so I'm going to turn this down. So we are covering Stanley Meyer and scalar chemistry. This was made by me, Elijah Coakley. All this is available on the internet, open source, and not able to be copyrighted. And there is a follow-up document that will be continued for development at the end of this document. So we'll be discussing essentially an intro to matter, Marcus theory, chemistry, Gibbs free energy, and that equaling the wavelength. And we're going to go into flowing water making voltage, like a water hammer on a molecular level. That's going to require some Maxwell equations. We're just going to go into a sneak peek of that, as well as fields and plasmoids. He is CEO of Crush College Chemistry, and as you can see, we got a lot of symbology going on here. From the legend himself, Stanley Meyer, as you can see, made the water-powered car with a water fuel injector. So the most abundant elements and noise of the environment can benefit all of mankind, turning static into Beethoven's Fifth, which is associated statistically with helping cure cancer. And so what we see on the right is this flower structure of these two triangles overlaid on top of each other. And we see that that is self-repeating in nature, from plants and biology all the way to materials and their structure, like this quartz right here, which you can see these optical field lines here. And this is how you can tell how you would cut a crystal for a radio circuit, for example. And so you can see it forms these constructive and destructive areas. To understand Stanley Meyer and his work, we kind of have to go into what water is and the building blocks of matter in itself. So, I'm going to see if Ryan's still here. Oh, perfect. You're still there?
I'm still here. Can you hear me?
I can hear you.
Yes. It's perfect. Most people know, but let's clarify. Water is H2O because there's two hydrogen atoms and one oxygen atom. Altogether, it makes a single molecule. But anytime you have a glass of water, you have tons and tons of individual molecules of water. And a hydrogen wave function, it is talking about the pathway of the electron that's surrounding the nucleus of the hydrogen. You think you could add a little bit more to that?
Yeah, so the hydrogen waveform takes on different modes, in my opinion, based off of vibration, which is set by the scalar wave. So it's kind of like the sound waves coming out of my voice with the air, creating high and low pressure zones. And the ether itself, which is the composition of space and time and light, that makes everything around us, 30% baryonic with rest mass and the rest non-rest mass. So 70% of the matter of the universe is like sub-H vibrations that travel right through the baryonic matter, for example. And my interpretation is basically there's this shadow and light. And there's essentially matter is shadow, which is kind of like base 3, the unobserved, it's the untouched. Whereas light is base 2. It's this dielectric field oscillating with a magnetic field, which is the cross product of two E fields, which is really driven just by an impulse, like a pressure wave. And so essentially what you see is the ripples being driven onto that pressure wave, which is the light wave. And so what I see with matter is implosion and explosion, constructive and destructive fields of interference, and the uncurled wave potential makes those ripples, and those ripples stack. And that stacking is the magnetic field or the current component, which is the exchange of energy or touch. And so I just want to point out, this is kind of like your base energy, whereas here we have this interesting quadrature structure, and we're going to note that later because of essentially this torsion field. And we see that torsion field generated in this great pyramid structure on slide 6. You can see that tiny little pyramid and the swastika. And essentially, all of matter here is flowing like a thermoelectric generator. We're going to get into that more. But essentially, you can see there's a negative and a positive, and there's a cold and a hot. And in between those fields of the light energy is the shadow of the regions that divide. And basically that has to exist because with implosion comes explosion, the hot of the light. And so you have to have the balance, because essentially North and South Pole are exactly like that. And that goes into this dielectric field potential. So we're on slide 7 now, and yeah, I just wanted to pick your brain. Have you ever heard of implosion technology before?
I've heard of implosion, but I haven't heard of implosion technology. Just kind of right off the bat, it kind of strikes me as applied psychology. Like you mentioned, I got a master's in applied psychology, and seems like it's exactly what that is. You take research, you take theory and science, and you apply it to an industry context. So can you kind of tell us what that is used for?
Yeah, definitely. So essentially, as we see here with the negative and the positive, one is flowing to the other like this, imploding and exploding. And we see almost this toroidal structure being formed, and the impulse of any fluid must form a toroidal structure to translate over space and time. And so with that impulse, we have a scalar wave, which is this delta phi term, which is like the sound wave. And then we have a vector potential associated with that, which is like the uncurled magnetic field line, if this is a bar, which would be associated with like displacement current density and drift velocity. But this in general is just your magnetic vector potential. Excuse me. And so I guess what I'm really saying is that there are no real monopoles. There's only a monopole depending on how you slice it up in space and time, and how you look at it, of like the positive and the negative, because one is connected to the other always. And I guess we'd have to go into Dr. Bratton's work to understand that more, but we're going to learn about that more later, as well as industry stuff. But essentially, what we see with the thunderstorm generator, have you heard of that? The thunderstorm generator?
I have not.
Essentially, it's just 3 spheres, like a 4-inch, 3-inch, 2-inch stainless steel 304 spheres, and you have hot gas rotating one way in between the outer and middle sphere, and cold gases that are on the intake of an engine counterflowing. And so essentially what happens is it creates plasmoids and transmutes carbon into oxygen, which we've seen on Bob Grenier, Martin Fleischmann Memorial Project, as well as Alchemical Science I have the lab results from the Chief Executive Officer of Intellect Research LLC. I can email you, but essentially it's the same as what's online with the Strike Foundation. And that's one example of implosion technology that I am basically also starting to introduce here. So this is kind of like our typical baryonic building block, right, on slide number 8. And this protium is the most common form. And I want to pick your brain on the structures on the right. What is your interpretation of how those form? Like, do you think the conventional Bohr model makes sense when we look at these structures? What's this
I
on
would say
slide number
not,
8?
because the thing about the Bohr model, right? So the Bohr model is hydrogen that has a proton and an electron. Now, that's protium. That's ion like what we see with protium. It is not particularly applicable to all scenarios, but it's very simple. It's very easy to understand because there's just a plus and a minus. So to answer your question, I don't think that the Bohr model would be applicable, but it could be. Who knows?
Yeah, I think oversimplified models are potentially useful, but they're limited. And so a model is only as good as its use, right? So basically, this Bohr model is good at understanding the periodic table in a sense, but it's not good at understanding harmonics and energy stacking through the field, because it's not taking account the particle wave duality. It's just missing the wave part entirely, right? So that's why we see protium the most abundant form, because it's pure positive and negative. It's pure dielectric field confinement, right? And that's what we see in these different modes of the waveform. And we see these different colors throughout, like a rainbow, because it's also like a thermoelectric generator, basically acting like a negative resistor. So going to slide number 9.
And
yeah.
right.
What's up?
So so just in case your viewers are not clear on this, protium, deuterium, and tritium, they're all hydrogen, but the difference between all of them is the number of neutrons. Protium has no neutrons, deuterium has 1, and tritium has 2. So that's why the mass number is different, but the atomic number is still 1 for each one. That's what defines hydrogen. It's because it has 1 proton, it identifies it as hydrogen. But when we go to the next slide, every single one of these elements is distinguished by a unique number of protons. That's what the atomic number in the top left corner of each of these boxes tells us.
Yeah, that's exactly right. So it's a baryonic building block, fractal harmonic resonating structure that stacks onto itself to make all of the elemental periodic table. So what do you think is significant about iron or cobalt, for example?
Iron or cobalt. So iron and cobalt are both transition metals. And the thing about transition metals is that they have d orbitals. Mm-hmm. And d orbitals are, there's a lot of different, it's not as simple as like a sphere, like the s orbitals are, or the p, which is kind of like a bowling pin. The d are a lot more complicated. And because of that sort of weird geometry, there's a lot more flexibility in the movement of the electrons. That's why, for example, iron is so, it can be very malleable. It can conduct electricity.
Yeah, that's exactly right. Iron switches flux amazingly. It's the last element in the sun that can be made before a supernova makes more, like heavier elements, for example. And that D block is like the wheel within the wheel within the wheel, as seen in the Bible, right? And so it's basically that central harmonic oscillating point, or near it, which is actually cobalt, as you can see at the eighth. So we see 9 here, the ninth column. So it's like 3, 6, 9 stacking, but we're on 8 here, in position essentially. And then 27 is 2 plus 7 is 9, 3, 6, 9, right? And so basically what we see here is it's at this point in the phi curve where it allows a scalar electromagnetic oscillation between left and right on the periodic table. So you can almost draw a line down cobalt and like look at iron, nickel. That's why iron and nickel together make an engine block really well. Um, yeah. And then I circled silicon because basically that combined with oxygen makes quartz, which has the chiral flow that we'll be discussing later. And oxygen, as we see, is paramagnetic. Um, yeah, paramagnetic, we'll go into that in a couple slides. And then moving on to slide 10
Absolutely.
here. What do you make of this color spectrum? And is there anything that catches your eye from a chemistry perspective that seems interesting to you?
Everything. There's so many things here. I first see that color depends on ionization energy. For those who are unsure of what ionization energy is, it's the energy that's required to input into an atom to eject its outermost electron. To like, and what's the difference between an atom and an ion? An ion doesn't has more or less electrons. Specifically, if we take off an electron, what do you think is going to happen? Do you think the atom is going to be positive, or do you think it's going to be more negative?
Right, if you take off an electron from that atom's perspective, it's more positive.
Right. You're taking away negative charge. And so, what does this have to do with color? Well, one thing that's really important to know is that the electromagnetic spectrum, which is light, has a certain amount of energy associated with it. So red, the wave that's red has more energy than the wave that's blue. So let's say the ionization energy was equal to the energy of a blue wave. You shine the blue wave in, it ejects the electron, and the atom looks blue because it connects, it resonates.
Well, that resonates with me. Because we're talking about, Marcus theory and sub H stacking to the Gibbs free energy equaling the wavelength, which has a specific band gap, right? So these different materials have different crystal structures, which have different gaps, and that basically is a specific amount of light refraction and stacking, i.e. impedance, right? And so we see these different bands shine through, and we see the collective energy of a color shine through as well. So like if you ionize hydrogen, we see this purple. We ionize neon, we see this sort of orangey color. Doubly ionized oxygen is green, right? And not only that, but the light forms interfering patterns, and depending on the energy level, you're going to have these different patterns. And so essentially those patterns create these torsion fields, and that centripetal acceleration is what's driving cyclotron resonance and different things like that. So we get all sorts of interesting behaviors with these gases and ionized things because they're acting like negative resistors, and that's why John Bendini used a neon bulb, right? I don't know if you know who John Bendini is, but essentially he made a pulse motor, and it uses impulse technology, another form of impulse technology that you may be unfamiliar with. And moving on to slide 11, basically water is another form of impulse technology. So your pH will play a role. The hydronium is positively charged ion, and so you got the protium H plus that can be knocked off, and then you have the remaining OH minus component. And so that's your pure potential. And essentially an altermagnetic field will aggregate the spin and make the voltage. And that's something important to note with the switching of a rutile. And essentially, when we look at the water molecule being bent and asymmetrical with charge, we see that a water hammer actually can make voltage. So if I open this link here,
thank you for calling Capital One.
My
this guy makes electricity with water,
and
these droplets. The hydronium moves away, but there's no hydronium to recombine.
I would recommend you checking this out on your own time. This isn't something we're going to cover too much today. But essentially, he creates a laminar flow with nodes about a foot tall. And that essentially creates enough voltage to light all these neon bulbs here that you can see. And that's like half of how many he could have lit if he wanted to, just so you know. And neon bulbs, they take like over 90 volts each to light, and it, they're all wired in parallel, I'm pretty sure. So they don't have a sort of runaway effect or increasing the voltage and burn up. But that's still pretty impressive.
Absolutely. And in case your audience is wondering, water is bent. It seems like water should be flat, because you have the oxygen in the middle, and then you have two hydrogens kind of like sticking out to the side. It seems like it should be like flat, but the reason that it's bent like that is because oxygen has 4 lone pair electrons, 2 pairs of lone pair electrons that require so much space because they have a large orbital that it like essentially like presses down on the attachments of the hydrogen. And so it creates this polarity, this difference of charge where the oxygen region is more negative and the hydrogen region is more positive, and that impacts pH. And pH is essentially a measure of how much water breaks down into H+, and that affects like your body. It affects different aquatic environments, and so just understanding how water is structured, it will help you understand everything to do with water.
Yeah, that's absolutely right. That's freaking spot on. That makes me pretty happy to hear, Ryan. So moving on to slide 12, we see exactly what he's talking about here. We see the negative side and the positive side. And imagine this was essentially microwaved. The wavelength of the wave is essentially on the scale of like insects, right? So it kind of creates these little pockets where the water can group together and spin. Excuse me. And so that spinning action allows it to heat up beyond the boiling temperature typically with its kinetic energy, but it doesn't boil over until you touch it, similar to how you can freeze something at the triple point. If it doesn't have a nucleation point or agitation, it won't freeze. But if it has too much agitation and turbulence, it won't freeze either, right? And it's kind of like that with the phase shift from liquid to gas with the Stanley Meyer technology, because of the water hammer effect of it flowing and its geometry. So just some interesting math to consider, this 104.5 angle leaves a 75.5 angle over here, and essentially if we take that 75.5 degrees and we subtract out 52 degrees approximately, which is a close to approximation of fluid going into a cylinder or a sphere to minimize turbulence, and that leaves 23.5 degrees. You divide 180 by 23.5 and you get 7.66. And so this is related to the Schumann beat frequency now with the engineering of the Earth itself. And I show this hourglass here because essentially we see an hourglass structure, and the hourglass is the inversion of the toroid, which I also show with the diatomic oxygen. And as well as a magnetron, we see the similar form of the axis of symmetry and the magnetic field lines stacking fractally, layering out, and the water molecule does the same exact thing. And so if you've ever taken iron filings that are magnetic and place it in the center of a magnetron magnet, they will accelerate through. So that A is representing movement, a charge asymmetry, which the water possesses. So when it stacks in the right way, it has that charge asymmetry as well. I want to pick your brain on slide 13, but I want you to just like look at it and just tell me your first impression.
Kind of looks like DNA. I am wondering why there are certain frequencies of light pointing at it. I can see the word chirality, and mirroring hands comes to mind.
Yeah. Those are some good points to see right there. I'm just going to go to this lightning strike first because I found this and it's really exciting because it's fun. Look how perfect that thing spirals, man. Like, that thing is like a perfect spiral. So chirality is kind of this, if you take silicon dioxide, right, and you look at the flow, it forms a spiral. And you can force the water to collectively form a spiral as well. And you see that the red line of water molecules in the stacking coherent spiral is associated to the infrared wavelength. And that is associated to the n=3 orbital, or the Paschen line harmonic of the protium. And the green spectrum is emitted around the 2.4 electron volt band gap when you have, for example, doubly ionized oxygen with the freed electrons from the protium with 2 water molecules split at a time to make the required sets. But anyways, you can see that the sum of frequencies can come in, and with every refraction there's a partial reflection, and we can utilize the refraction and reflection together to make micro vortex structures, and those structures, because they have that chiral nature, it starts forming a coherent living water structure that is more similar to a Bose-Einstein condensate. And so you can kind of look at this patent, which is associated with gravity shielding here by Ron Kita, and it's basically a benzene molecule that's rotated in a uniform magnetic field. And what sort of effects do you think that would have, considering we're talking about ether flowing?
That's a really hard question to answer.
That's okay. You don't have
Because
to
I mean,
know.
when you say benzene, yeah,
Yeah.
like I remember there was benzene is when you have a hexagon of carbons with like 3 double bonds and a hydrogen extending from each carbon, and I think there's some sort of like it's like kind of like flat, and there's like negative charge that's like on top and below, if I'm not mistaken. I would definitely like. There's got to be some polarity of charge going on right there.
Mm-hmm. Yeah, it's like a spiral.
Mm-hmm.
Excuse me. So essentially everything is vibrating. Everything has a temperature. And temperature, sound, vibration, crystals being LC circuits connected to electromagnetism, that being connected to the spin of the electron of all electrons with photons observing no time, we see that sound is inseparable from temperature and thermoelectrics. And so the vibration structures water, the structured water structures voltage, and that can structure other things to do work in our environment. So I have basically this plate showing cymatics, which is a form of structuring materials into areas with vibration. And he's pinching this spot, and it kind of creates these 5 equal divisions, like a pentatonic scale. So I pulled up the A minor pentatonic, and he's basically pinching the B note. And we see that F sharp is Earth's crust resonance from the Great Pyramids with the radio frequencies, and silicon dioxide being the primary material in Earth's crust. And so we can start to piece together a sort of chord being formed. And we also see this sort of geometry encoded with math, being 5 plus 4 equals 9, 9 being a fractal number, being encompassed by 3, right? 1 plus 8 is 9, 2 plus 7 is 9, so everything composes into itself like that. And so we see with the semitones of 5 plus 7, E and A, it equals 12, which is the convergence of the square, the root 2 curve on slide 17, and the phi, the basically Fibonacci spiral or golden spiral. But taking a step back again, we almost can start to see a form of AC current being analogous to the ACE chord being played, for example, if that chord were to be played. And if you want to look at this Anu electricity on your own time, I encourage you to do so. Basically, it's always changing the form of energy, so you always have a form of flux. And so with that, you can transmit energy over space and time. Yeah, check out slide 15. What do you think those green and yellow pictures are? Have you ever seen anything like that?
I have not. It kind of reminds me of like a d orbital.
I thought so too.
Yeah.
So I'll scroll back up to slide 8 here. And looking at the d orbitals, we got different shapes like rings within rings. I guess maybe it looks most similar to 4D's Sub-Zero, almost layered on top of itself, doesn't it?
Yeah.
Do you see that with the two rings that are faded on the diagonals? And so one is orthogonally oriented to each other, and so you basically actually have three, one going in and out of the page as well, stacked on top of itself. The ring within the ring within the ring. And it's almost a form of RF cyclotron resonance with scalar waves and form of RF, right? So essentially the applied RF is very little change in the ion energy, so we can take advantage of high flux and sub-H vibrations. And so the ion can appear to be stalled and just coasting. At the 90-degree phase limit, that is. And as Malcolm Bendall put it, you would square the circle. And so that's where we get some of this geometry emerging from. We see this sort of square within the circle in these repeated patterns. Going back to slide 10, that image on the right in the middle, with the quadrature, you see the square, the circle, the four nodes. And we're going to see that pattern repeat over and over. It's going to be awesome.
Interesting.
So I'm not going to go through all of these references, but essentially Bruce Swartz, he died, but he made a YouTube channel, Bruce Sees All, and you should definitely check it out later. And these are infrared captures of alien reproduction vehicles that you're looking at. And the reason why Stanley Meyer is dead is because it's related to this technology through water and sacred geometry and scalar electromagnetics. And it's not to be coveted or be secret or owned by anyone. It is a part of our biology even. But that's besides the point. Essentially, the Merkaba is something that's like the quartz crystal. You take an equilateral triangle, three-dimensional, and a prism type thing, and you invert it and overlay it, and you kind of get that hexagonal torsion field. And if you have two torsion fields pushing into each other and equal and opposite, you get this, what I believe to be the Merkaba energy, which is essentially you take this cube, you draw an X on each face, you erase the lines of the cube, and you are left with this remaining structure in 3D. And what this does is absolutely amazing. It's a short video, so we're just going to look at it. Okay. So this is Merkaba energy, and you can see the simulation is basically concentrating charge into a location. So it creates a topological monopole, even though it's not a real technical monopole. So this is creating voltage, essentially, in my opinion, which is a form of frequency. And
En hier bij Stanley Meyer, nu
Stanley Meyer,
garage. En we hebben net zijn...
he basically pre-ionizes
We're ionizing the ambient air gases
the ambient
that are
air
now
gases
going into the
in.
process, and this allows us
And that's with
to
the N
trigger
equals
and use
2
the
on the
hydrogen fracturing
protium.
technology and tapping into a higher energy yield coming from the
And then he
hydrogen.
taps into a
The unit you see right here, this is
sorry,
the
N
first
equals 3, and then he taps into a higher energy, N equals
control,
2.
so allows us now to release the thermal explosive energy from hydrogen.
And basically he's releasing the thermal explosive energy from hydrogen, he says. And yeah, I'm going to go on to slide 17 because I think this is kind of the bread of the butter mathematically of what's going on. Do these spirals make you feel any certain way when you look at them?
You know, I've seen these spirals before. I would have expected, because I see all of these are upside, all the numbers are upside down. I would have expected the numbers to be rotating 90 degrees every new section. And because of that, it makes me feel a little bit like not necessarily disoriented, but sort of like I have this sense of like disequilibrium.
Sure. Yeah, disequilibrium is a good word. It's almost this untapped force that's not really understood or realized, the centripetal aspect of the ether flow, right? That's how I kind of see it, and it can stack in different ways. So on the left, we see like base 1 being protium. We count at 0, 1, 2, 3, 4. We see basically this x root 2, so this is a square. And each one of these is forming nested squares that stack. And you can divide it however you want, but eventually it stacks onto 1, 2, 3, 4, 5, etc. Likewise, this other curve, 1, 1, 2, 3, 5, 8, 13, etc. It stacks as the Fibonacci or golden spiral. And as you've noticed, it doesn't just go like 90 degrees every time. It's like 1, 1, and then 1, 2, which basically sets up this diagonal line. Just like how the Merkaba was a diagonal line on the square. And just like how bismuth is stacking into itself. And so basically it forms these nested squares. And we see literal nature do this as well, with my coffee even, on the bottom right. So this allows for nested harmonics between basically the observed and the unobserved. The observed is the base 2 based off of the base 1 of the baryonic matter, and the unobserved is the trinary, which is the shadow, which is the implosion. Because you cannot observe a black hole past the event horizon, that is. And so essentially base 2 and base 3 collide at 12. In time, on a clock, they share 0 and 12 because they are at the same. Now, I'm no expert, this is just my personal perspective on it. Now, Marcus theory is a special case of non-radiative. Marcus theory is a special case of non-radiative decay theory. Its basic principles can be applied to a much wider range of physical theory. Its basic principles can be applied to a much wider range of physical and photophysical phenomena, including excited state relaxation dynamics. In the Marcus normal regime, region, the zero-point energy of the Lagrange field excited state, which equates to its driving force for ground state recovery delta G naught, is smaller in magnitude than the reorganization energy, which is your wavelength, associated with converting from that state back to the ground state, which is like open to the environment, right? It can suck in energy from the environment. This leads to a condition in which an increase in Lagrange field strength results in an increase in the rate of excited state relaxation. The phenomenology of decreasing excited state lifetime with increasing driving force, the Marcus normal region remains valid until the driving force and reorganization energy exactly offset each other. At this point where your Gibbs free energy is equal to your wavelength, that quantization energy, i.e., is this barrierless region where the activation energy for the process, this is where it's important. The rate of the reaction is dictated solely by the electronic coupling between the two states. Frequency of light is not limited by a human perception of a spectrum. Just, frequency is 1 over time. What is the limit on time when the universe exists? None. And so Marcus inverted behavior basically allows us to open up an enormous possibility for lots of compounds and metal catalysts for photoredox reactions. And why this is important with impulse technology is because when you consider cutting a crystal and making an LC circuit or something, if you have an overcoupled system and you turn on and then you turn it off, when you turn it off it has a larger spike than when you turn it on. You see what I'm getting at with what John Bendini was doing with the impulse technology, for those who are familiar with that? So I want to pick your brain on slide 28. Like, Gibbs free energy. Why is it called that? Why is physics so dogmatically fighting anything that basically enables us to get energy from the environment and consider that a part of the system? And why is chemistry so open to call it Gibbs free energy? It's in the phase change process to do work, as well as chemical change. And the work is already paid for by the sun in the protium. So we have to trigger an input energy, which is open to the environment. You can decouple it from the load with high Z impedance. You can feed through that with drift velocity, and the crystal lattice refraction can drive coherent waves called the Bethe-Hilter process. And this is a reversible process.